After the general introduction of green roofs, in the second part we are focusing on the consideration of green roofs. Green roof as a naked flat roof can be built up with different layer sequences. We know three types of layer sequences. One is the conventional layer sequence, second is the inverted layer sequence, and the third is the dual insulated roof layer sequences. The layer sequences differ from each other in the sequence of the different roof insulation layers. In case of conventional roof systems, the sequence of the roof insulation layers are the follow: vapor barrier, thermal insulation, and waterproof membrane, as we are going from inside to outside. In case of these flat roofs, a vapor barrier must be installed to reduce vapor penetration into the insulation, as vapor release ventilation, which could be point or linear, can hardly be solved technically and would be objectionable from the aesthetic point of view. This type of roof is more vulnerable for moisture effect, even with such vapor barrier. Therefore, its application should be avoided for new roofs. For re-roofing, if the existing thermal insulation and vapor barrier layers are appropriate from every aspect, this type of construction is acceptable. In case of inverted layer sequence, the waterproofing membrane is located below the thermal insulation. These flat roofs with reverse layer sequence are much more favorable even with respect to vapor. Here no vapor barrier layer is applied, so the number of layers is reduced. It means that these constructions are more simpler. At the same time, we should use such kind of heat insulation layer which is resistant against every outside effect. For this reason, we could use only closed cell polystyrene heat insulation material, so extruded polystyrene, or we can use also glass forms. Which is also mentioned that we need a suitable heat storage capacity below the waterproofing membrane. It means that the surface density of the load-bearing structure should be at least 250 kg per square meter. If we have lighter load-bearing construction than this, we should provide vapor barrier as well. Since we have light heat insulation over the waterproofing membrane, we should place adequate mass above the insulation to avoid floating of this heat insulation board. However, in case of green roofs, it's obvious since the green superstructure is providing us enough mass to fix and avoid floating. In case of dual insulated roofs, we can find thermal insulation material below and over the waterproofing membrane. In case of dual insulated roofs, vapor barrier is not necessary, but careful vapor diffusion planning is always required. Dual insulated roofs are very common in case of renovation. In this case, the originally built-in insulation layer, if it's suitable, it will form the lower thermal insulation layer, and on the top this layer sequence we will create an inverted roof. So on the top of the waterproofing membrane we will have again an extruded polystyrene thermal insulation layer. If we are preparing a re-roofing, the structure usually consists a vapor barrier, which is the original vapor barrier of the layer sequence. Dual insulated roofs are very common in case of passive houses, since we have possibility to place adequate thickness of heat insulation in the layer sequence. On this picture you can see the different roofing system, the conventional roofing system on left, in the middle you can see the inverted roofing system, and on right side you can find the dual insulated roofing system. With numbers, each layer is marked, and in the next slides we are going through on these layers and their characteristics. The first layer, which is marked with 2, is the load-bearing structure. There is no special requirement for the load-bearing structure. We should apply massive structure such as monolithic reinforced concrete or precast reinforced concrete panels are most suitable. The load-bearing capacity and rigidity, means deformity of the roof decks, are very important parameters, because the roof soil and the vegetation can form significant part of the total load. According to data of the relevant international literature, the dry specific gravity of the individual roof layers can be considered with the values that you can find on this slide. The next layer is the sloping layer, which is marked with 3. The main role of this layer to provide slope for the waterproof membrane, which is placed above the load-bearing structure. This layer should be made from gear-well concrete if possible, but lightweight concrete layers or the stepped thermal insulation sheet is also used to reduce the screed thickness and the mass. If we are using lightweight concrete layer or stepped thermal insulation to create the screed, we should know that they are vulnerable in respect of vapor diffusion. Therefore, special attention should be paid to moisture and vapor control of the roof structure. The required slope of the screed is minimum of 2% on the roof surface and at least 1.5% in the roof valleys. Provision of the required slope for green roof is even more important than for other roof types, because damages originating from insufficient water drainage can be repaired later only with difficulties, and generally locating the place of fault is not a simple task. Sloping layer created from stepped thermal insulation could be made from mineral wool or polystyrene foam heat insulation board. In the picture you can see roof where the sloping layer is created from mineral wool. To create such kind of sloping layer, we should design it properly in advance, and the heat insulation boards are arriving to the building site with marks, and a prepare consignation plan is required where to place these elements to create the adequate sloping layer. The next layer is a vapor barrier, which is marked with 4. This layer can be an aluminum foil with a thickness of at least 0.1 mm, which is generally produced in a laminated form where it's combined with a bitumen sheet. Application of vapor retarding layer, which could be a plastic foil, can be only suitable if vapor diffusion resistance of the waterproof membrane is low, so we could apply it only such cases when we have soft PVC insulation layer or EPDM as a waterproof membrane. In case of bitumen sheet waterproof membrane, due to the high diffusion resistance of the material, we could only apply aluminum foil to create an adequate vapor barrier. The next layer is a thermal insulation layer, which marked with 5. The thermal insulation layer for conventional roofs or the lower insulation layer of roofs with double insulated layer can be any thermal insulated material which has enough load-bearing capacity. In this respect, we can use rigid plastic foams, or we can use mineral wool as well. Most used material is extruded polystyrene foam board in case of inverted roofs, which have T and G edges to eliminate thermal bridges. The material characteristics are low water absorption, freeze resistance, chemical resistance, compressive strength, and very good thermal insulation. These thermal insulation boards can be laid only in one layer, otherwise a water film could be formed between the layers, which works as a vapor barrier. This is a limitation of inverted roofs. That's the reason why in case of passive houses the dual insulated roofs are spreading. Or we can mention the expanded polystyrene drainage trays also, which are fulfilling also water reservoir roles in the layer sequence. The next layer is a separating and protecting layer, which is marked with 6. In most cases, this layer is made of plastic film or felt, usually polypropylene. The function of this layer is surface equalization, so it gives protection of the vulnerable membrane from mechanical impact, especially in case of PVC or EPDM membrane, which is quite thin waterproofing membrane. But it's also separate the base and the insulation if they are incompatible chemically. It's again usually required to separate the soft PVC waterproofing membrane and the rigid polystyrene thermal insulation boards, because these two materials are incompatible chemically. The next is a waterproofing layer, marked with 7. We can use any kind of waterproofing material. Bituminous sheet, PVC or EPDM membranes are very common. Only requirement that the waterproofing membrane must be root resistant by its material and connection. For this reason, welded membranes, PVC or membranes which are produced with vulcanization like EPDM are preferred. The next layer is the protecting layer against roots, marked with 8. For this purpose, generally large size polypropylene or soft PVC foils applied. Because these foils generally cannot be welded or stuck together inside, extremely large overlapping used, which means that 50 to 100 centimeter wide overlapping applied, or we could lay it in double layers. Around the outline of parapet walls and superstructures, the root barriers should be carried up to the height of the edges of the waterproofing, that is at least 15 centimeter above of the top roof soil. The next layer is the water holding and draining layer, which is marked with 9. This layer is very important if we are talking about green roofs. The basic objective of this layer or layers is holding, retarding and storing of water necessary for the vegetation, and also very important that this layer providing a quick drainage of surplus water from the structure in order to avoid soil became waterlogged. And this layer is suitable also to provide ventilation of the green roof structure. Material and element choice for this layer is fairly wide, and in addition to holding and draining of the water, these materials and products often suitable for performing other functions as well, like filtering the rainwater or providing extra heat insulation. The traditional way to create water holding and drainage layer is the drain filling, to create drain filling from round river gravels. On the right corner you can see a porous plant tray made of polystyrene. These trays are widely used since these are taking part in the fixation of plants. The roots of the plants penetrating into the pores of the trays, grabbing the material. Plastic trays formed by die pressing and made from hard and rot resistant plastic, mainly from PVC, are frequently used as drainage layer. You can see here in the corner the two types of these plastic trays. These trays have a small wall thickness and the rigidity is ensured by the shape, and they can bear quite much load also due to this shape. Due to the profile formation of these trays, where you can see that on the bottom two directional channel system is created, the surplus water drainage is provided quickly, and these channels let the ventilation also for the green superstructure. On the top there's a quite big storing hollow where water could be stored, and on the top we have holes where the surplus water from the soil could be also drained away, so we can avoid the soil became waterlogged. Drainage trays made of thermal insulation materials are similar to the previously described ones, but due to their larger wall thicknesses and thermal insulation capacity, they can also fulfill the function of an upper thermal insulation layer. In the following slides you can see a special solution provided by the OptiGreen called Solar Green Roof, which is a specially developed system that could provide a secure base for solar power modules. It's very important that these anchor points are fixed by the load of the soil layer. It means that it's a safe solution to provide standpoints, anchor points for solar power module. The vegetation also grows beneath the modules, and in this case it's enabling the largest possible roof surface area to be greened. In addition this, since the vegetation provides a cooling effect through evaporation, this increasing the output of the solar power system by 5%, contrasting to the other positions, other hot retaining roof surfaces. You can read more about the advantages of these modules on OptiGreen homepage. The next layer, which is just below the roof soil layer, is the filtering protecting layer, which is marked with 10. This layer stops that fine soil or nutrition particles being washed into the water reservoir layer from the roof soil and would reduce its permeability. For this reason, generally fine woven, non-rotting plastic textile felt is used, which have considerable tensile and bearing strength. Few words about how to design green roofs, the designing guidelines. In case of green roofs, the fire protection is a very important question. Researchers found that purely theoretically a green roof fire can occur by two ways. First, when the planted vegetation or the wild growing grasses are drying out such an extent that after self ignition the total burning of the whole surface can occur. Other possibility when the roof soil containing organic materials which are causing open fires. In case of extensive green roofs, we can mention also the fire which is caused by the dried out vegetation, especially where there is no regular maintenance. German researchers laid down requirements and duties to be performed by designers or operators which are necessary. German researchers laid down the requirements and duties to be performed by the designers and operators for fire protection of green roofs. In the following slides we are going to look through these requirements. First requirement that boundary walls and firewalls and fire breaks should be constructed at distances not more than 40 meters, and these structures have a minimum height of at least 30 centimeters above the ground level. The second one, if there is no special fire protection requirement relating to the building, so there are no firewalls, fire breaks, we should separate between fire sections by creating 100 centimeter wide strips, fire protection strips. It's usually made of concrete panels or wrought gravel filling. The distance between these fire protection strips should be similar than the distance between boundary walls and firewalls. Means that minimum 40-meter distances we should create such kind of fire protection strips. In front of roof superstructures and roof openings, a fire strip should be created from non-flammable materials with a width of at least 50 centimeters. The material could be concrete panels, wrought gravel filling, or other material which have fire resistant. Other important structural question, designing question, how we solving the water drainage in case of green roofs. The water drainage of green roofs takes place at least 2 and in certain cases in 3 planes. The first plane, of course, the main plane, the waterproofing membrane. The second plane, the top of the thermal insulation, but certain number of waters, certain amount of rainwater could be drained on the vegetation surface as well. The roof drains should allow the control and cleaning possibility, so therefore on the top of the drainage points control box should be placed. Different manufacturers providing proper solution for control box and grills which could be placed in front of roof doors and terrace doors, terrace windows. On the pictures you can see a control box made by the Egyetem company. It's made of modules, so it's easily adaptable for the required soil thickness. In case of wall flashing, we should mention the following requirements. The waterproofing should be carried up over the ground surface at least 15 cm on the parapets, walls and all the superstructures. It's possible the root protection layer also should be carried up such a distance. It should be ensured that the drainage layer is ventilated along the wall edge through the gravel filling, since this providing proper living conditions for the plants. The parapet walls along the edges of the roof should be covered by any kind of waterproofing system. Application of aluminum profiles pressed or bent from sheet can be recommended. However, special attention should be paid to its upper ceiling, since they are usually made of elements, so the connection should be watertight. It is very important also to place box gutters, what you have seen in the previous slides, along the superstructure. These gutters prevent water accumulation and play also a fire protection role as well. It's also important to provide safety railing system on the roof structure to protect falling accidents. Closing the lecture, I recommend you the Egyetem company's virtual house homepage, where you can easily find the detail which is required to solve your own project.